So this is poisoning web-scale datasets is practical. I apologize if my voice is a little rough. Against better judgment, I decided to go and sing karaoke with some friends last night. And in addition, they're not allowed to use stickers anymore, so I'm tatted up temporarily. So this is some research that we did together with some titans of research that are throughout the industry, Google. If you've read any sort of research, you'll recognize most of these names. And really, this is kind of their research, and I'm here for a fairly specific reason, which I'll get into later. But I've been attacking machine learning models for a while at this point, and one complaint I have about ML research is it tends to focus on the impact, rather, and not whether or not the attack is possible. So attackers always have to work with whatever access they get, but ML researchers, they have access to everything, and so they can loosen their assumptions as it relates to the research or the research problem that they're trying to solve or the mechanic that they're trying to highlight. And in general, it's like, why should you have access, white box access to a model? And you really shouldn't. And that's, as we start deploying these things into production environments, those assumptions will inevitably not produce, I think, useful research going into the future. But then if you look at the headlines, a lot of our headlines look like this. And this is a slide I've been giving for quite some time. It might actually be like 3 years old at this point. And if you look closely, you'll see Carlini's. Well, you won't see Carlini's name in this one. You'll see it on the next one. But this is what we see in the media, right? But if you're sort of an ML security person, this is where you spend most of your time, like reading papers. And truthfully, what you see in here is actually just this. So you have academic researchers who are sort of releasing a lot of research. And then it's my job as an operator to take their research and then operationalize it against whatever system that we happen to be attacking. Much like maybe an exploit dev will write an exploit, but they're not going to be the ones to use it on the host. And so that's where I get my POCs for stuff. And if you're in this space and you're looking to attack machine learning models, this is where you should be. There are several papers that have attacks against production systems that are just mentioned in the report or in their paper without really any sort of thought or consideration as to notification or things like that. They have sort of different standards than I would say the security community does. But let's suppose you wanted to train a state-of-the-art model, or really any regular model. Doesn't necessarily matter these days. Things like Hugging Face make it extremely easy for you to just go pull a model, pull a data set, go learn some things, and go train a model. In the 90s, you would have used MNIST, and so this is your 101, right? It's 50,000 images, 28 by 28, has 10 classes. It's everyone's maybe first entry point into machine learning. I was kind of barely around in the 90s, but it won't work for state of the art, so we can't use that one. In the 2000s, you had CFAR 10 come out. It's 50,000 images, 32 by 32, slightly bigger, but still 10 classes. They're color, which is kind of nice, versus grayscale. But we can't use that. 2000s have ImageNet. It's got 1 million images, 1,000 classes, and again, color images versus grayscale. But again, you can't use that either. And so what people have started to do is they've started to aggregate these really large data sets. So this is Lion 5 billion. It has 5.85 billion image text pairs, so that's quite a lot of images to look through. But it's a large data set, and it's used to we do this one, obviously. It's a large data set, and it's used to train things like the OpenAI CLIP model, StableDiffusion, and all of these kind of big Mid-Journey, all of these big models that we've started to see come up onto Hugging Face, into our products. The whole generative AI piece that's being deployed into I don't know, your Windows or the Avatar or Teams or any sort of everyone wants generative AI at the moment. Except there's a few issues. You can't host 5 billion images, or people generally don't. Cost. So just storing 300 terabytes of data for the general public. Licensing, copyright, and trademarks. So it's 300 terabytes of the internet. Who knows what's in it? And so organizations can't store it because they'll have to, there's trademarks, copyright. There might be PII in it, for example. And just because, data is public doesn't mean it should be public. So, but there's no sort of, data scientists aren't quite there yet, so they just took 300 terabytes of the internet and decided to train their models on it. But how do you distribute a data set with 5 billion images? You don't. Like, it's a lot, so people don't. So what they do instead is they basically create, this is a picture from Hugging Face, so they basically create a list of URLs where you can grab the data, along with some metadata. So you see here the URL, the text string, and then some other machine learning metrics that are useful to machine learning folks. And then, if you couldn't see it, I made it a little bigger here. And then they'll release a tool. So there are kind of multiple big big data sets like this. And they'll release a tool. It'll be like modality to data set. So it'll be like text to data set or PDF to data set or something like that. And this is how people who want to use this data set will go and pull down the model. So you'll spin up a big cluster. They'll go and load all the URLs in, and they'll just go pull down that data set. And the reason that I'm here giving this research, and not at the academic conference that the other researchers are at, is that domain registrations expire. And as we know, based on the groans, when they expire, anyone can buy them, right? And so here's Nicholas Carlini, happiest man in the world, who now owns 0.01% of Lion. Nicholas wrote, or Dr. Carlini, Nicholas, he wrote a paper earlier or last year where he basically came up with the range of an upper and lower bound for the percentage of a data set that you need to control in order to do some arbitrary poisoning task. And it's between 0.0001% and 0.01%. And so whatever 0.1% of 300 terabytes is, maybe 30 gigs, is as much data as you need to poison a state-of-the-art model, which I don't think is very much. But he also owns 0.01% of all of these data sets. So when you get a big data set like this, what happens is it gets chopped into other data sets used for other things. So they'll go scan, like, hey, this is a data set of every horse we could find in it. And they call it horse 700 million or something. And so there's like some shared overlap there, or there's some overlap with the domains that these data sets use. And it doesn't affect just image data sets. This was the research, and it was actually just wonderfully scoped. It also affects text data sets. And so here's some sort of traffic analysis. We can see people pulling down our images. I shouldn't say pulling down because we didn't poison because we were not allowed to. But you can see people trying to pull down the data set, right? And our images are not there, but there are many other images that are not there. Like the internet is just, it's a volatile place, so servers go down, domain registrations change. And the data set that was collected at time 1 is not the same at time 2. And so what happens, so this is our kind of our first attack. And it's called, we call it split view poisoning. And this is where a curator basically will publish a data set. And how you go about it is so the curator will publish a data set. You'll check the registration of each domain, and you sort by just the number of samples in that data set. And then you just go, well, after you sort it, then you go and check the registration, and if it's available, you'll just buy it. And then you can upload or not upload your poison content. But at that point, any subsequent collections of the data set have this content. So it kind of looks a little bit like this. And all of these curators will publish their usernames, or sorry, their user agent strings. And so you can sort of filter out legitimate traffic from not legitimate traffic. And because they do collect so much data from the internet, they'll often tell you, what their user agent string is, and so so people can put it in like robots.txt, and prevent scanning or whatever. And so we can use that, and we can sort of measure how people are using the data set, or measure who's pulling it down. And there's a little more, but there are a few issues with the way this works. So just because you can control that amount of data in a data set doesn't imply that you can actually poison it, right? So you can poison it, but you have no control over how it gets processed, or what the task is, or what gets filtered out, or how it gets subsetted from the large training data set, which is not ideal if you're an attacker. But if you maybe have some base models, or what model they're training, you can pull it down from Hugging Face and go and train a model like this. But it's not, it sounds bad, and it is bad, because for the last few years I've owned several domains in these data sets. It's a bit like having physical access to a host, right? Like, that's how I think of poisoning, is having physical access to a model, where you can sort of send it any arbitrary data, give it any arbitrary task. But to really know if you've succeeded in poisoning, you'll need to find it again somehow, right? Like, you'll need to find, or you might not know how it gets deployed. So maybe it's being deployed in a generative context, or maybe it's being deployed in a classification context. You have no guarantees, right, that that data is going to be input into the model in any particular way. But in any case, you can still get your data in. And actually, that image to data set library that I was mentioning, and it's been a while since I've looked, but the last time I looked, it wasn't actually checking what it was downloading. It was just sort of checking for the file path extension, so JPEG, PNG, all of those images, and then not checking, like, so you could be downloading PE files, you could be downloading Word documents, right? You have no idea. And there's even more. So there's, once you understand that you can gain positive control over, some input into a model, whether that's through text, whether that's through like a prompt for LLMs, like you might be used to, or whether that's through poisoning or some control over the data set. There are actually a lot of places that you realize that you can sort of poison a model. And I think these would be the more familiar ones. So the ones I've heard are, GitHub. You can upload a bunch of code, and now you have a percentage that you can target. Reddit, and then Wikipedia. So any sort of public repository of information that you can gain positive control over, you can poison. So this is a little bit of, this is other research. Or, sorry, not other research. This is the same research in the same paper. It's quite long. But basically, we have positive control over a public website, and then we learn when scraping happens. So they publish it. They publish like how they scrape, what they scrape, how it gets built up into the data sets, and then how you as a consumer can go and pull it from Wikipedia. If you're a machine learning person, you want to train a model, they'll tell you how to do it. And so researchers we basically, with our domains, or with our, we would poison, make an edit in a Wikipedia page, and then time, like when it was changed. And so we got this little jagged chart here where you can see how we became better at, well, better at predicting when, the edits would be reverted. And so what ended up happening is we would be able to make edits and then revert them immediately, so after scraping. So then, it kind of bypasses any manual checks that people would make. People are angriest on the internet, and so, if a Wikipedia page is wrong, they're very quick to change it. And this is the paper. So this has actually been out for a year or more. It's been rejected from like 3 academic conferences at this point, which is kind of wild. We actually had, it's a brand new process for me, and I'm mostly just watching. But we had one reviewer that was like, "You should do this in real life." I'm like, "Can't do that." Yes, so we do propose defenses in the paper. And those are sort of just your classic security things. So are these hashed? Can you detect changes in your data set? Can you see like what has changed, what still exists, if nothing else? Can you track what your model was trained on, or future iterations of the model were trained on? All of the models out there currently, like there's no way for you to say this was trained on this data set because it came from the internet. And I know it's not because I've changed it. And so as security people, I don't know, we need to like help data scientists out and just bring some like basic practices in, like cryptographic descriptions of data. And we also notified the dataset curators. So these are like big organizations, and we had mixed reviews or mixed responses. Some people were really excited. They were like, thank you for this. And then some people didn't respond, and then some folks were kind of mad about it. But that's security research. So that's very mathy. I don't know if you read the paper. Actually, we did AI red team training this year. This is the first time we did it. And in the email that we sent out to students beforehand, I added just 5 papers. And I didn't add them for any particular reason other than to give students the feeling of reading an academic paper and being completely lost, which is kind of mean, to be honest, but that's kind of how it is. Sorry. And I think they were a little lost. But so as security people, like, what can you do? If you're not into math, if you're not into linear algebra, you never liked your calculator. Sorry, this one's a different one. What can you do? If you read in the bottom description, he says, our attacks call into question whether training on noisy and uncurated internet scrapes is desirable. It's not, right? And that's something we all know and we've learned throughout time as a security people. And so this is kind of where researchers are, and that's their job, right? So when you go to archive and you read a paper, it's not written for you, and you don't understand it and you're lost, it's because it's not for you. It's for their peers. Just like when we write a blog and it's half done or it's just mostly code, that's written for us. So when researchers read it, they're like, yeah, this just lacks any sort of rigor whatsoever. And it does, but it's not for them, right? It's for us. So this is kind of how I show up here. I was at Microsoft, fresh out of consulting, and we used to do these things with Fundamental Fridays with Dr. Hiram Anderson. I don't know if you've met him. He's an awesome guy, super kind with his time. And he took Fridays, we would just spend an hour, and he would teach me math, and I would teach him offensive security. And we're doing like large language models, and he's talking about common crawl in the data set. He's like, yeah, so we, common crawl, they take a snapshot of the internet, they scrape it from the internet, and they use it to train models. And I was sort of like, what? Say that again? And so that was sort of the genesis, right? And to me, it was just instant. Like that was the world. I'm not sure if you've seen, or if you know of Nick Landers or Monarch's Gas. He has like a flying a false flag presentation that was given at Black Hat 2 years ago, I think. But in it, he basically has this technique where you would register a domain as a business, let's say, or a subdomain, whatever. And in the cloud, you'll assign an IP to that domain, right? But let's say the domain expires, or no, sorry. Then you will release that IP. It goes back into some cloud pool, right? But then the DNS record still exists. And so this idea that there's like it's not done in the same action leaves dangling DNS records. And so I had just left Silent Break. So this was like fresh on my mind. And so that it was just immediately obvious that I was able to buy domains, get them scraped. And I was very excited to hopefully do this research. And at that point, I didn't have the machine learning skills to do it. I wasn't going to be able to do it. But I knew that I could buy domains, and one day it would be useful. And here I am. And here's this research. And so through Hiram Anderson, I was able to meet up with this group and do this research. And so I think sort of the message here for me is, just bring your security skills. Like, you don't need to know math to have an impact in this area, right? There's a CVE for LangChain, and it's just an eval statement. And I was talking to some peers, and they were sort of like, I didn't even think to look for eval, because that's just not something we do anymore in production settings. And so we have all these mature tools to go application testing, but we're going to look for eval statements, or MLflow doesn't have auth by default, or every ML tool is built around pickle files, which has been in CTF since 2013, maybe. But as a function of that, every ML tool now needs to support a pickle file. So at some level, there's just an ability for that to be mishandled and create code execution in some really odd places, or not odd places, production environments. For example, you have an MLflow instance, no auth. It's used to pull and deploy models that are pickle files. But it's done. Like, you just replace the model. I have a colleague, John Irwin, who released a pickle wrapper last year, 2 years ago at DEF CON. So we can just inject shells into pickle files while the model still works. And it's been kind of awesome. Or even Jupyter. We have a Jensen deepfake model that we've stolen from off the network. And that was just in an unprotected Jupyter notebook that we got access to, right? And now we could call whoever, and it sounds like our CEO. We haven't, though, by the way. Our VP of Research is sitting in the front row, so I feel like I need to clarify that. But sort of, these are takeaways from the talk, or just this talk, right? It's a fairly simple mechanic, right? It's for us, it was obvious based on the groans, but it is. So everyone talked to, and then when you mention this to data scientists, you can sort of see the cogs like turning, and then they get it. But they can't necessarily do anything about it, right? Like, they're data scientists, they need data. So I think there's going to be some process by which we're going to have to have data sets that are somewhere between the internet and pre-production. So data supply chain's hard. Like, that's just it. Like, S-bombs for software are starting to be a thing. Do we have the same for data sets? No. So we're kind of at square one. Exploitation is not guaranteed, as we talked about, which is tough. right? You might have to come up with some sort of canary that you can go search for in a deployed model to figure out, what impact you actually had. And I think ultimately, you can't trust any model that has been trained on any of these data sets. And nor can you verify that they haven't been poisoned. And they're everywhere. So that's StableDiffusion, that's ChatGPT, that's Claude, that's, it's everything that, Llama, it's just everything. Not only that, but every day there's a new data set that someone on Hugging Face has released that is a set of URLs that they're using as a metadata store that anyone can do. So as of now, for the last forever, you've been able to do this. So you could go home right now. You're not going to get the same data, but there are so many domains and there is so much data. And you'll probably see another research paper from that group. And I kind of just wanted to talk just briefly about if you're coming from security into this space, that you shouldn't be afraid to dive into the papers, into the math, into the confusion. A lot of it is maybe not relevant. So security people are always so concerned about finding the exact mechanic, right? That little thing that's clever and gets you the code execution that you want. But math's just not like that in some sense, right? I'm sure there are definitely spaces where that is the case. But generally, modeling and things is about experimentation. It's trying a lot of different things in a lot of different ways with a lot of different metrics, and then tracking those metrics across time, right? So you can build up some intuition and knowledge about how a model interacts with the data set or interacts with the environment that you have or that you're going to deploy it in. And so if you're a security person and it's frustrating to read those papers or implement it, I would say just give yourself a break for not being up on the last 1,000 years of math, because it's hard. People have been doing this for a long time, PhD folks have been in school for ages. I'm not actually even sure how long it takes to get a PhD. Forever is what it. Actually, my favorite PhD student, Giorgio Saveri, should look him up. I was like, Giorgio, how's it going? He's like, my life is terrible. and that's, he's a PhD student because he was studying for exams. That's one of my favorite quotes. But and then just find the framing that works for you. Just keep turning it. Keep working on it. Keep reshaping. Just keep working through it, and eventually it'll just click. And there's a few moments I can remember where I just hit that next level. And it was awesome. But then you sort of get to look down and be like, oh, I was struggling for kind of a silly way, or kind of in a silly way. And then if that fails, there's always 3 blue, 1 brown, which I highly recommend to just everybody. What else do I want to talk about? Let's see. Yeah, academic and research and security. They're bound by different sort of rules. They have IRBs. They want to be very ethical. They need to make sure that everything's above board because they want to publish. So they're responsible for publishing research. They're not responsible for attacking your systems and telling you that it's broken, right? That's our job. And so as you go through, and I used to complain that it's oh, this is not real world. It's very real world. You see it as images, and you don't understand that images are just numbers, or text is just numbers, or audio is just numbers, right? And I think, to be a little cliche, at some point you get to sort of just this point where you're yeah, it's this is the Matrix. It's if you're looking at me now, just imagine every millisecond you're taking a camera, right? And then turn those into RGB values and throw it into a model. And it's like that everywhere. And yeah, go to archive and just look for your products in these research papers, and you may or may not find them in there. That's it. So I want to say a quick thank you to a few folks. Nathan Hamiel, who's the track lead for the data science track here at Black Hat. He's always dropping in, being like, hey guys, to the AI Village Discord or whatever AI community there is. He's always dropping in and just keeping us up to date on what's going on. And obviously, can't imagine how many ChatGPT papers he had to read through this year. A couple friends, Nick Landers and Trevor Alexander, who, when we first started looking at this like a number of years ago, they were both extremely encouraging. And then I think if I was going to say leave you with one thing before we get to questions, it's that algorithms are empty and models are not. So as you start moving these things into production, if you're training them on PII, like it's in there somewhere. Or it's a compression, it's a compressed representation of data. And so just because it's machine learning doesn't mean it gets a pass on security. Yes, it's exciting. Yes, it has the ability to create enormous value. But to bring your production environment down to the level of ML security right now would be a terrible idea. And so just try to bring it up in whatever way you can. So whether that's application testing, whether that's just asset inventories, whether that's like RBAC, 2FA, like just put all your data scientists in one network, make them 2FA into it, and let them have at it. Or even standards like, yes, you can use Pickle in this dev environment, but once we move to production, we're going to use Onyx as our store. And then as I left Microsoft, it was sort of, when you learn about optimization, you're trying to minimize a value, right? And then it's very mathy. And so this is like the Dunning-Kruger effect, where you think you're great, even though you're not, and then you get to this bit. And so if you're an optimizer, like you want to be at this low point, but what I've learned is that this is a local minimum. And so there's more to learn. There's lower than this somehow, right? And so as you go through, just keep learning. Just understand that this is just part of it, and that you're just stuck in this local minima. And at some point, through iteration and learning and all of those meta machine learning things I'm thinking of right now, you'll get there. And if it's not for you, it's not for you. That's OK. But if you really want to dig into it, like you should absolutely. It's an extremely rewarding field of study. And those are the last two. There you go. That's it. Thank you so much.